But let me introduce the people who you haven't met yet. Arlen Nipper from CirrusLink, right? Arlen is one of the two original developers of MQTT, so he speaks with some authority on that topic. Benson Hoagland is with Opto22. We have Frederic Debian, I probably don't say it right, but from the Eclipse Foundation. He's a Canadian, but it's a global organization. And then last but not least is Kevin McCluskey. So what I'll ask is if you folks who have not presented could just briefly talk about what you are doing and what is your connection to Sparkplug or MQTT? I guess Arlen should be. Yeah, you have to make that brief for in your case, I guess.
So, hello everybody. I'm Arlen Nipper. I'm the CTO for CirrusLink Solutions. I'm also the chair for the Sparkplug Working Group. First of all, I want to thank AMRC. That was a fantastic presentation. I've seen Todd's before, but I really got to accommodate you guys on what you did. It was pretty fantastic. So, I invite everybody to find out what the Sparkplug Working Group is, find out what we're doing, look at the press release on being able to have a technology conformant kit to test your MQTT client implementation so that Todd knows that when he gets that driver from you, it's going to be compliant. It's got a Sparkplug logo for it.
Hello, everyone. It's good to see everybody here on a Thursday, late Thursday. My name is Benson Hoagland. I am Vice President of Product Strategy at a company called Opto22. We're a hardware manufacturer. We're one of the PLCs that Todd described. And real quickly, I've been with Opto 28 years, and about the first year that I came to Opto in 1995, we were already underway on a project to try to solve some of the problems that we're describing now, but problems of the day. And that problem was, how do we get plant floor devices to communicate on an IT network using the Windows operating system? As a result of that, in 1996, we co-developed and founded the OPC Foundation. So Opto was one of the initial developers of that, again, to solve problems at that time. And there's been a lot that's happening in OPC arena, we all know that, but the problems that we face today are different. And that's why we're involved in the Sparkplug Working Group and why we've been shipping products with Sparkplug B natively built in and with Ignition on those systems for several years now. So that's our role.
All right. Is this? Yeah, thank you. I'm Frédéric Desbiens, so you are close enough. And I manage IoT and edge computing programs at the Eclipse Foundation. So my role there is really to create an environment where those guys can innovate. That's literally my job description. So essentially, I keep an eye on a number of open source projects that we have in the IoT edge space. And Sparkplug as a specification is one of those. And then on the other side, part of my job is also to evangelize the technology and specifically, put it in front of new audiences. One very important thing about what we do is really the vendor neutrality in everything that we do, in the sense that we are this vendor neutral steward for Sparkplug as a technology, and we own the trademark and we own some things on the behalf of the community, but ultimately it's those guys who drive the show. It's those guys at the technology level that decide where to want to go, and it's my job to create conditions for that to be successful. So thank you for being here, and especially in this post-party day, to have the courage to be there. I really applaud you.
Yeah, and my name's Kevin McCluskey. I'm co-director of sales engineering at Inductive Automation. And if you take a look at the Sparkplug list of companies or logos that we've had on slides over the years, and you were to add all the different logos on there, I think Inductive Automation would be the first. So we've been involved with Sparkplug and with Arlen and his team from the very beginning. We have been involved with a lot of different projects that a lot of different companies have done, and providing guidance and working with them to help bring it to success. And obviously the Ignition software and our platform has Sparkplug built in as one of the things that folks, when they purchase a license of Ignition, they can just say, I want Sparkplug, right? I want the MQTT modules from Cirrus Link. And so we're happy to be here and happy to be talking to you guys.
Okay, great. I appreciate that very much. We have enough time, I think, so I'm going to ask a couple of questions that I can't resist asking, and then I'll quickly turn it over to the floor. But I wanted to start with Frederick. And can you explain, in particular, the governance of this project, what Eclipse Foundation is providing? You mentioned vendor neutrality, but and I'll follow that up with a question, because it seems to me that this is a specification, not a implementation. So I wonder why, what the relationship is there for Eclipse in the case that it's not it seems to me it's not an implementation. So could you talk about how the project is governed and how it fits into the open source world, if my impression is correct that it's a spec, not an implementation?
All right, so let's get into open source politics then. Well, the simple answer to this is really that at the Eclipse Foundation, traditionally, well, first, when we started in 2004, we were literally one project, the Eclipse IDE. Love it, hate it. That's fine, because now we have 420 plus projects, so plenty of good technology over there. Around 2011-12, we created the Eclipse IoT Working Group. And what happened there is that the very first projects we had were Eclipse Sparrow, Eclipse Mosquito, so a set of clients and an MQTT broker. So MQTT is literally in the DNA at the Eclipse Foundation. Now, the type of governance we have for projects is under what we call the Eclipse development process. And how this works is that essentially our projects have to follow a number of rules, being transparent, open to the community, and meritocratic. Okay, so each project at Eclipse as open source project has a project lead and committers who have authority over the repository where the code lives. And then it's up to them to organize. I mean, I don't have hierarchical authority. Of course, I can provide guidance, I have opinions, and I bounce ideas with community members, but ultimately it's up to them to decide where they want to go, as long as they follow the process, right? So sometimes we will remind them, hey, time for your annual review, please publish your roadmap and things like that. But, that's the extent of my authority over those things. Now, in 2018, roughly speaking, we introduced the Eclipse Foundation specification process, which was a new thing. And at the time, we were taking over Oracle as the home to Java Enterprise Edition. So we created from the ground up a spec process to manage this huge set of specifications. I mean, you have no idea how complex this can be. And that's great. I don't have ITER. That's not my domain. Whew. Now we have a set of very mature processes to govern, those specs and the open source implementations that go with them. Okay, and so in the case of Sparkplug, they benefited from all of that hard work when Cirrus Link contributed the Eclipse Sparkplug specification to the Eclipse Foundation. Okay, so they deliberately took that step of, putting this spec into our hands. So at Eclipse, the specs are open in the sense that they are built in the open on GitHub. So you go there, you can see the in-progress version of the next version of the spec. And you've got the TCK, the Technology Compatibility Kit, so open source code that you use to validate your implementation. And all of that is built by the committers of the project, which is literally employees from Opto, Cirrus Link, Inductive, and IVMQ, and others. Okay, and all of that, comes from them. Okay, so essentially open specification, and it comes also with an open source implementation, which is the Eclipse Tahoe project. That's a very...
Sorry, which project?
Eclipse Tahoe,
okay.
T-A-H-U.
Okay.
And once again, the initial contribution for that was from Cirrus Link, so thank you for that. And the relationship between the two is that this is not a reference implementation that has special status over others. We require at Eclipse every spec must have at least one open source implementation. There can be several open source implementations that don't necessarily live at Eclipse. We know that at the Linux Foundation, for example, the Fledge project has a Sparkplug connector, okay, that they developed, and that's fine. But really, we require at least one open source implementation and then any number of commercial implementations or even other open projects like Factory Plus that build on the technology. And we own the copyright to the text of the spec, and we just, it's free to implement, royalty-free, free to redistribute. We just ensure that, once again, nobody takes it and then runs away with the trademark or does strange changes to the market. Once again, in the idea that we keep those guys from fighting. No, they are all good friends. We create a level playing field among those people to work on the spec and optionally on the implementation.
Okay, thanks, Frederick. I have one more question that I'll ask, and that I'll maybe throw that at Arlen. Can you characterize the working group and what you do? I think people here are familiar with kind of the working group concept, but can you characterize the working group for this and who's participating, who are the committers, that kind of stuff?
Well, the committers are so first of all, once you've joined the Eclipse working group, everyone that joins can have a committer that works in the committer. Now, other committers can come in and start committing, and then they can be voted in as committers and don't have to be on the executive team. The Sparkplug working group, you saw all the logos up there, Cirrus, Inductive, Opto 22, HiveMQ, Canary Labs, AMRC. We have monthly meetings, bi-weekly, right? Seems like every week, but we have bi-weekly meetings where we review right now, our main goal was to take the Sparkplug spec that SiriusLink gave to them, that I initially wrote it all in Word and I was explaining the world, and we got it down to all the normative statements, and we cleaned up a lot of the word. And that we're trying to release, version 1.0 in the July timeframe, and then have a reference implementation that goes with that. That is what we as the working group are trying to work towards. Schedule that, get it approved, and get it out in the market.
Okay, thank you. Now I'm going to shut up and let people from the floor ask any questions that they want. I appreciate your forbearance. Okay, I'll give preference to an end user over ARC. Don Bartusiak, go ahead. Can you wait for the mic though, Don, so we get it recorded?
Thanks. Don Bartusiak with Collaborative Systems Integrations. So I've heard the phrase unified namespace, but I don't understand what it is. Can somebody give us maybe just a brief explanation of what unified namespace is?
Who's going to pick up that one?
Okay. So that actually kind of came out of the blue for me as well. Walker Reynolds is an integrator, does a lot of factory integration. I will have to say, 6 years ago, I did the first MQTT demo ever. I was at Inductive Automation. Nobody knew we had done MQTT engine. I said, hey, I'm going to connect to 500 PLCs, 250,000 tags, and we're going to get it all in less than 30 seconds. And we did the demo. So this one guy walks up on the stage. It was Q&A time. He didn't talk to me. He grabs the mic, turns around to the audience, and he said, "This is the future." And it was Walker Reynolds. And he ultimately started the Industry 4.0 group, and he started this whole notion of a unified namespace. What that means is that using MQTT, maybe not necessarily Sparkplug, but using that, you build a topic, because the way you publish information is you want to be able to subscribe on a known topic and then be able to discover everything. That's where the plug and play comes from. So what the unified namespace group are doing is saying, hey, we should use this topic namespace, use this tag name structuring, so that every time we add a device, it's just going to come in and populate. And that's going to be unified across our factory. Now, they're not dictating it, so strict. They're saying each customer gets to pick the best way that they want to do their unified namespace based on what they do. So if I look at Phillips 66, I know that, well, we've got the topic namespace of a pipeline, so it's pipeline 1, and then it's booster station 1, and then it's PLC 1, and then it's process variable 1. But if I'm in a factory, that's probably a completely different unified namespace. Does that answer your question?
That helps, Arlen. Thanks.
Okay.
Okay, next question. Peter, I'm gonna go over there. I don't know who that is. I'm ignoring my colleague. So please identify yourself and ask your question.
Ramses Verbrugge, Dow. Very interesting presentation, so thanks a lot for all the details that you shared. And I have a question. I've seen MQTT before and very interested in the technology. And I wonder, how do you position yourself compared to things like OPC, which also kind of overlaps, I suppose, with what you're working on? So
I try not to get into an MQTT versus OPC UA because I think we need and will have both technologies going forward. We use OPC UA all the time, to Todd's point and to Benson's point, is that OPC UA for brownfield equipment is going to be around for the next 20 years, at least. Right? So we're saying that there's a right spot to say, let's go from, closed loop, very fast polling, or anything that you would do with OPC UA versus having this one-to-many architecture where you just publish things. I don't care who consumes it. And then on the other side, I subscribe, but I really don't care where it came from.
And in our perspective, we are technology agnostic as well. So we have Eclipse Milo and OPC UA implementation at the Eclipse Foundation, which comes from inductive automation. Great work by Kevin Aaron there, among others. And ultimately, it's up to the market to decide. Not me, not ultimately you, but collectively, what makes sense for a specific project and a specific implementation. So of course, we have a vested interest in Sparkplug. We created this working group because we believe in its potential. But ultimately, we will work with other open organizations like ourselves, and we will, take wherever our committers take us. That's our mission.
Okay. Go ahead. Somebody else wants to contribute?
As a long time implementer of OPC, I can tell you that I believe that OPC is an important part of this process. The reality of the world is we live in a brownfield environment. And as Arlen just described, OPC is going to be out there for a long time. So when at a local level, that's what we use. We use OPC to talk to an Allen Bradley PLC or a Siemens PLC and be able to pull all that data, model it, and send it into infrastructure via Sparkplug B. But OPC is a key component of that at that local level. So that's where we benefit from it. And in this case, we also use Ignition and their drivers, which takes all those tags, makes them OPC, model it, and send it on up into infrastructure. So it's still an important part of a complete solution.
Okay, next question up here. Peter, you didn't raise your hand that time. Okay.
Hello, Roberto Pena with DuPont. So my question to you, and really to any of you, as you said, we've got a lot of brownfield facilities out there. What have you seen as business justifications for either integrating or to even transitioning to MQTT, type or Sparkplug type devices?
Well, let's start. We want to start with Todd. Is that okay?
Yes. So the value that I see of doing that is being upstream oil and gas. We've got SCADA towers everywhere. All right. We want to have quicker speed to all of those locations. Well, what's the cost of doing a radio upgrade to get that last mile to get, 10 meg a second capability out there? That's very costly. All right. If we can use the same radios that we have now, but reduce our bandwidth to 15%, we add a $500 to $1,000 edge device on top of the PLC, convert it to Sparkplug, and do that, reduce our bandwidth over there and put it to a broker. We don't have to spend time upgrading our radio systems. All right, and it's an Ethernet-based protocol. It's already there, it just happens. So it's a lot less time, work, and money to do that than the alternative.
Anyone else? That question was addressed to everybody. So does somebody else want to comment on the types of installations? Maybe
Alex?
Benson or
What about you in the fact?
or Kevin?
So I'd like to echo what Todd said, really. For us, it's all about how quickly we can onboard new devices, right? We have, as I said, we have all sorts of devices, different protocols. Being able to convert them to Sparkplug at the edge and not worry about the rest of the architecture is a game changer for us. And as well, looking forward, scalability. So our partners we work with are looking to roll out digital architectures across their organization, and having one that is lightweight, flexible, scalable, like Sparkplug, is really appealing to them.
One thing that we've seen from inductive automation, we work with a lot of customers who are using Sparkplug, MQTT, and OPC and other technologies. As was mentioned, one of our developers is the main developer of Milo open source OPC UA stack, and we were one of the first companies to actually implement OPC UA outside of the reference architecture that they created. So, we've been working with that for a long time. I've seen a lot of folks taking a look at their infrastructures, and rather than thinking about replacing the pieces that are already there, converting everything over to MQTT and Sparkplug, just taking a new system. So if they're putting in something new over in this area, to take a look at the communication protocols that are in that section and say, oh, we're now reevaluating, should we be using Sparkplug? Should we be using MQTT? All right, maybe let's give it a shot over here, see the value that we get out of this. We understand the conceptual value that has just been talked about here, right? What do we actually get as business value? What are the dollars and cents? What's our return on investment? New project, new communication technology, and then maybe it does make sense to roll it out to everything else. But at that point, these companies are being able to see some of these numbers and be able to see what value their engineers are getting, what quicker development. That's sometimes one of the returns on investment there, and then lower bandwidth, easier on the infrastructure, that type of thing too.
I will add, there's one thing that our customers gain tremendously from an implementation of MQTT and Sparkplug, and that was their need to address cybersecurity. Doesn't really come up as much as you might think when you're talking about MQTT, but let's remember, OPC or many other technologies out there are traditional client server. You have servers out there on a network, and they're listening. So security obviously becomes very important. The beauty of MQTT as a pub-sub model, I get to publish data into infrastructure without opening any ports. So right out of the gate, my cybersecurity footprint is far simpler, far easier to implement than traditional client-server architectures. So that's been a big deal for our customers, knowing that they can protect their systems, yet still democratize all the data from those OT systems into infrastructure for any software to consume.
The other thing I want to add to that is the modernization of the PCN. If you don't do the pub sub in the PCN, I was talking about property swaps. We could take that and, when are we going to control from the cloud? I don't know. But at least you could, if you don't have the infrastructure available, you can point it to the cloud, and over a cellular connection, you're not going to get killed with data charges, right? That's one. But it's just having it there ready to go and be an enabler for the future rather than having to try to catch up, because you're not going to pull Modbus tags from the cloud down to there. If you have no other options for connectivity, this gives you that piece that it's a really repoint and you got the data.
Okay, back to the floor in the back. In the left rear, we have a question.
Yeah, Arlen, you can speak to some of this, but
Just please identify yourself.
oh, my name is Alan Ray. I consultant. We'll go with that.
Fair enough.
So one of the things that we ran into, myself and Doug Miller and a few others, as we were working through edge connectivity, the security that we get to be able to really be able to lock down incoming ports, have a persistent out where you're really meeting that Purdue model, is great. Here's the problem. Everything I publish and I say, this is writable, if you have the URL, the username and password, I now can make a change to that tag back down at the edge. So we went through some work with Inductive and was able to validate that. But what is the roadmap for Sparkplug B to, because I don't think we played any games, and Kevin, you may know this, but I think what we achieved was good, but what's that look like for the identity management at the edge with rights with Sparkplug B?
Well, that's a question for the team,
Yeah.
I guess.
What we did was that the extensibility of Sparkplug, what you're talking about, we'll probably kind of go low level here. It's called a D command within the Sparkplug verb. So a D command is using the Google Protobuf payload, and that D command can contain as much other metadata as we want to. So what we're able to do in your case with Ignition is be able to take the operator's credentials that sent the command and then add that to the D command payload so that when it got to the edge device, we were able to validate that the person sending that command actually had permission to send it and then go ahead and execute the command. Now that will be, we're trying to get Sparkplug 1.0 out the door, but that will be very easy to add that into the overall Sparkplug specification. And I think to me, that's what's interesting with Sparkplug is that the payload is extensible. So we can add other metadata, we can add other properties, and still we don't break Sparkplug vernacular, if you will. To Todd's point, we added the ability to publish files, which means I can publish JPEG images, I can publish vibration data, things like that. We're looking at the D record command, which lets me do things like read pump cards and publish a block of unmutable data. All those things are possible within the Sparkplug specification.
Okay. And your roadmap, just to follow up on that, your roadmap is right now for second half of this year to publish
Right.
this spec. And
But anybody can
implementation.
go in there and do a pull request and say, I want to see this. That's the involvement within the Sparkplug working group, is that I'm sure, as you guys can tell, I've been in oil and gas for 43 years. I probably don't know that much about other sectors that I need to know. What do we need to add to Sparkplug to make it relevant for other industry sectors?
And yes, as you mentioned, Harry, we are introducing, we had a press release earlier this week announcing the launch of our compatibility program. So essentially this means that products that pass the TCK will get to use this nifty Sparkplug compatible logo as a sticker on Benson's devices, or a little logo on the box. Do you still get it in the box when you buy Inductive? Anyway. So when you see this logo, and we'll have the full list obviously of compatible products on the Sparkplug website, you have the assurance that it fulfills all the requirements in the spec. And this operates like Sparkplug itself. Sparkplug is about simplicity, right? The full spec is less than 100 pages, and that's even if the character size is a bit big. So you can get it smaller. But simplicity for the spec and simplicity for the compatibility program, because essentially we operate on a self-certification model. So I would love to have millions of dollars and a certification lab and all of that. I don't. So what we do is that we put the TCK, which is open source code, okay, into the hands of implementers as a binary. So to pass officially the test, you need to get the binary because we don't want you to fiddle with settings. But ultimately, when you pass that, you submit a public statement that, okay, the TCK gave me this file, okay, that says that I passed all the tests, and I'm making a public statement legally binding that I fulfill the requirements. Okay, so now you would say that maybe people will try at the margin to do weird things, but if they do that, it's about their public reputation. So this is what self-certification is about. The fact that people are making in public truthful statement about their compatibility, and then, you know, it's up to the market to decide. And ultimately, if something happens, we have a dispute resolution process and all of that around that to make sure that we resolve any weird situations that could arise. But we trust implementers to do the right thing. They get a fantastic, royalty-free spec to implement as they wish. And if they want to claim compatibility, they just have to pass the TCK, and all of that is public and fully documented.
Okay, another question over here.
Sorry, just to
Go ahead.
just a quick comment.
You're
on that.
welcome to. Go ahead.
As one of the people doing weird things in the margins, from an implementation standpoint, going back to the cybersecurity side of that, in the first instance, everything that you want to do as a node is defined in the birth message. So if a node, it has its credentials, it has everything, tries to do something, issue a command that it didn't say it was going to do when it first came online, that triggers a response from the primary app to say, what are you doing? You know, you need to rebirth yourself. You need to say that you're going to do that if you're going to try and do it. So there are things in Sparkplug to defend against that.
Okay, further questions? There's a hand over here. Okay. Didn't mean to take it away from anybody.
Shane Robin, Tampa Electric Company. Along a similar lines, we're still talking about security, and you guys have mentioned a couple times in some other presentations, no need to open ports, you know, that type of thing. Can you talk a little bit about how it transverses a firewall without, you know, opening the ports, and how do I sell this to my firewall guys that now are relinquishing control? It's like, oh, now I have no way of stopping what you're sending through.
So MQTT Sparkplug, being MQTT in general, does use a port for outbound comms. So you have one server, or in a redundant situation like the MRC guys described, redundant brokers, each of those is a single port in the system. That's 8883. At the edge, outbound is not inbound. So I can allow data to pass through. It's just like if you open up your laptop, you go to google.com, you put it in a search term. Google doesn't know anything about, you know, they can't get into your computer. They can't get onto your network because you have those ports closed. You've created a connection, you know, right? You gotta be a little careful with phishing attacks, but that's a topic for another day. But the point is that I can make an outbound connection, and with MQTT, we persist that connection, and that channel is TLS encrypted. So it's not able to be attacked from man in the middle or anything like that. And that's how we get state, that's how we move data, and in the event of a D command or something that has to come back through, back down to the edge device, that's how we do it. But no port at the device needs to be open for that. Now,
But you have to have a port to connect to the
broker.
Yeah.
That's, you know, a single port in the system, and IT loves managing one port, not 1,000.
A quick note for those of you who aren't familiar with TLS. TLS was mentioned. It's an encryption for that connection. That's the same technology that your banking website uses. So when you go and you log in, and you know, it's encrypting that communication back and forth. It's an industry standard. It's something that IT departments like. So TLS 1.2 or 1.3.
Okay, we have some more questions, I know. So thank you, and hand over the mic. And that fellow there, that's Elko, I think. I've got a light in my eyes, I can't tell, but go ahead.
Change the question. My name is Ilko van der Wal. I'm the managing director of the organization PLC Open. And I just wonder, if you add so easily an object, how do you validate that? How are you sure that it is allowed and it's not part of a hack?
Oh, sorry. No. I was going to mention, so part of the communication, part of the client to broker communication. One, it's encrypted like we were talking about. It also has the ability to have username and password authentication. That's part of it. But in addition to all of that, there's also the possibility of using client certificates. And that means that rather than allowing anybody to connect to the broker and be someone who's an unknown actor who's just sending something through and it's a hack, right, or somebody's trying to get into it, you can set it up so that that broker is only accepting connections from known actors that are outside of it, known systems that have client certificates. So you copy those around beforehand. That's a secured thing that you have secured on your network. It's not just sent over the network, and it's something that your security team controls. So those client certificates, it needs to verify that signature, that identity of what the device is that's connecting up to it. In order to do that bidirectionally. And that's an option. It's not required for every connection, but you can turn that on. And if you turn that on, that has even additional security there.
So you limit yourself a little in the flexibility. In the example from Chevron, where it's very easy to add an object in that sense, you have to redo your broker.
So either on the broker you would accept the client certificate, or you'd be copying that server certificate over as part of that communication as well. So you have a few options there, depending on which devices you're using and which MQTT servers you're using.
Okay, thank you.
And on the top of that, there are also access control lists in MQTT that you can use to add an additional level of, security.
And I think it should be noted as well that when MQTT was created, I'm really speaking for you here.
It's your fault.
It was KISS, right? It was keep it simple, stupid. So what Arlen didn't do, and Dr. Andy Stanford Clark, the other co-inventor of MQTT, is they didn't try to build a security mechanism into MQTT. And we haven't done that as well with Sparkplug B. We rely on TLS encryptions we just described. In other words, industry standard methods for creating secure, authenticated connections between the devices that are communicating. And as we see progress in those TLS type encryptions and authentication methods, we benefit. The Sparkplug community benefits, the MQTT community benefits. So I think that's an important distinction. Rather than bottling it all up into the spec, we get to rely and leverage all the work that others are doing, including banks and so on that are using the same technology. We get to leverage that at a Sparkplug B level. Did I say that all right?
Yeah, you said that fine. Other questions? I'm looking for a hand here. I don't see one. Oh. All right. Now, I could ask one more question, but I'm really not going to do it because it's about 7 minutes before the forum is scheduled to end. So give me one last chance if you have another question. Oh, there's one. Okay, you got one more. Better to come from outside than from me, so go ahead.
Jeff with Canary. Arlen, I've had the joy of getting to know you well, but I've never asked you this question. At what point what was the pivotal moment for you where you and the team at CirrusLink said, hey, we need to develop a specification for MQTT? Was there something special that happened, or what's the story there?
As you can imagine, the first payload, or the first topic payload that I designed was for Phillips 66. It was very efficient, and it was also so cryptic that I probably could have never documented it. So we had done the first MQTT module for inductive. It was just kind of generic. And I went to a trade show in Chicago, and Travis Cox was on a round table, and he said, oh yeah, we do MQTT. And then Moxa said, well, we do MQTT. And then Opto22 said, we do MQTT. And Hilscher said, we do MQTT. And so I went around to all those vendors, and I said, well, how do you do it? And everybody did it different. So as I always say, the great thing about MQTT, and the reason it's become so adopted throughout IT, is you can publish anything you want on any topic. The problem is you can publish anything you want on any topic. So the reason that we wrote Sparkplug originally was for our own sanity to say, look, we've been doing this for 20 years, you know, lessons learned, things that we wished we'd have done that we didn't, and that was the genesis for Sparkplug, is to get interoperability, to get plug-and-play capability, and get MQTT back into the space that it was actually invented for in the first place, which was operational systems.
Okay, with that, I think we'll draw this to a close. I want to thank our presenters and our panelists for an informative session, and the forum concludes with a box lunch, so there'll be box lunches out in the lobby, and it's usually a very nice time for the next hour, hour and a half, or however much time you have to sit with your peers or friends you have made at this event and share lunch. So thank you all for coming, and please give this panel a round of applause.